Okay, welcome everyone to Sec 3 end of year chemistry, combined chemistry, revision. Okay, so just a self-introduction first. My name is Shannon. I graduated from NTU with a chemistry degree. I was a lab teaching assistant as well for year 1 students. So my role was basically to disturb year 1 students and scare them that the experiment went wrong. Okay, then I tutored for 4 years and I am teaching actually for 7 years already. So why is that tutoring and teaching? Because I started my teaching career as a music teacher part-time while I was studying uni. Okay, so why did I carry on teaching is because I found joy and purpose in helping students like you all to succeed, and I think that is very fulfilling. Okay, so just a quick self-intro. Moving on. Okay, so for today, I'll be covering 4 key topics, starting with elements, compound, and mixture, followed by atomic structure, chemical bonding, and acid and bases. Okay, so first up, elements, compounds, and mixture. Okay, the first thing that we need to know is elements. What are elements? Elements are pure substances that cannot be split up into 2 or more simpler substances by chemical processes. What are some examples of chemical processes? Electricity, heat, or light. Okay, when I use heating, when I use light, when I use electricity, it doesn't break down any further. It's already the simplest form. Okay, and how do I check if something is an element or not? Just refer to your periodic table. Okay, next, element only contains one type of atom. As you can see in the diagram, right on the right, you will see that there's only one kind of ball or one kind of atom. Okay, and elements are pure substance. What does that mean? Elements will have a fixed melting point and boiling point. Some examples of elements include Ne, which is neon, Na, which is sodium, okay, and H2, which is hydrogen gas, O2, which is oxygen gas that most of you all should know, and Cl, chlorine gas. Okay, so from these examples, we can see that there's only one type of element. Okay, so for the first one, okay, this is only made of one atom. This is especially your noble gases, which is found in group 0 of the periodic table. Okay, so if you have a periodic table, you might want to get it so it's easier to refer to as I explain the concepts. Okay, and what about this? These will be examples of hydrogen, oxygen, and Cl2. Okay, these are still considered elements. Okay, there's only one type of atom present. All right. Okay. Next, we go to compounds. Compounds are also pure substances that contain 2 or more elements chemically combined in a fixed ratio. So for example, we all know that water is H2O, right? So what does that mean? One unit of water contains 2 hydrogen atoms and 1 oxygen atom. That's what this chemical formula over here means. Okay, so that's what I mean by fixed ratio. 2 hydrogen atom, 1 oxygen atom makes up 1 unit of water molecule. Okay, so I want you all to think of atoms as like your single Lego block. Right? I think most of you all have played Lego as a child, right? Okay, atoms are like your basic building blocks. Okay. Compounds also have a fixed melting point and boiling point. So for example, we mentioned water just now. So most of you all should know that water will melt at 0 degrees Celsius or freeze at 0 degrees Celsius, and water will boil at 100 degrees Celsius, right? Okay. So this is only provided that the water is pure. Okay, if the water is impure, then things will start to change. Okay, but that will be under the purity chapter, which is chapter 3. Right? We learn how to separate mixtures and we learn how to identify purity of substances. Okay, but I won't go through that today. Okay. So some examples of compounds. Okay, this is carbon monoxide, water. This is nitrogen dioxide. Okay, and we have the famous sodium chloride, and we have calcium carbonate. So from these chemical formulas, you can see that there are at least 2 capital letters. Each element is represented by a capital letter. Okay, so there's 2 elements over here, 2 elements. Okay, this is 2 elements. Okay, this is a small letter. So this is 1 element. This is the second element. Over here, I have 3 elements. Okay, so this compound is made of 3 elements. The rest are made up of 2 elements. Okay, in comparison to the element slide just now, okay, you can see there's only one type of atom. So hopefully this distinction between elements and compounds is clear. Okay, if you have any questions, feel free to type in the chat. Okay. Okay, then now we come to mixtures. Mixtures are substances that consist of two or more substances that is not chemically combined together. They are only physically combined. Okay, so an obvious mixture example would be sand and water. Right? What happens when you mix sand and water together? Your water is going to be at the top while your sand is going to be below. Right? They are not going to form chemical bonds. They just remain as it is. Sand remain as sand, water remain as water. There's no chemical bonds formed. They are just physically mixed together. Okay, and mixtures do not have a fixed melting point and boiling point because they consist of two or more substances already. It's impure. Okay, so if you ever see this word or phrasing in exam, you need to know that this is referring to an impure substance, and then you link it back to a mixture. Okay, so what are some examples of mixtures? We have air. Okay, this one has a chapter on its own in the future. Okay, airs actually have a lot of elements and compounds. You have your water vapor, carbon dioxide, oxygen gas, all of these things floating around inside air. Okay, and you have steel, which is an example of an alloy, and you have salt solution. Okay, this salt solution basically is salt water or seawater, right? And just now I also gave this example of water and sand. So these are example of mixtures. Okay, but the thing is there's three different kinds of mixture. Okay, from this first diagram over here, I can see that there's one element over here and there's a second element over here. So for diagram 1, I will call this a mixture of elements. Okay, mixture of elements. This is for your diagram 1. Okay, moving on. I can see a compound here. I can see two different atoms, right? So this is already a compound. Compound 1. I can see a second compound here. So for my second diagram over here, this is a mixture of compounds. Okay. Now my third diagram, I can see an element over here. I can see a compound over here. Okay, so remember, do not be confused. Just because there are two atoms doesn't mean it is a compound. It's only made of one type of atom, right? So it's still an element. Over here, I can see a purple ball and blue ball. It's made of two different type of atoms, so it's a compound. Okay, so I will call this a mixture of element and compound. Okay, so there are three different kind of mixtures that we need to know. Okay. Okay, next, we need to know the differences between compounds and mixtures. So usually the first three is what students will often remember or memorize and write for their exams. Okay, usually exams will ask you up to two lah. Okay. So the first one, compounds can be broken down by chemical means, okay, such as electricity, heat, and light, previously mentioned, right? Okay, mixtures can be separated by physical means. So what are physical means? This will be your chapter 3, separation techniques. Okay, filtration, crystallization, distillation, all these are considered physical techniques used to separate components in a mixture. For example, just now I gave sand and water, right? How do you separate sand and water? You simply carry out filtration. Okay. Alright. So for example, water can actually be broken down into hydrogen and oxygen gas. Okay, so if I were to write 4, 2, okay. Water can be broken down into hydrogen gas and oxygen gas by electricity. So electricity is actually an example of a chemical means. Okay, but for combined science, unfortunately or fortunately, you will not learn this. This will be under pure science, okay, where they learn about electricity breaking things down. Okay, compounds have a fixed composition. Just now I mentioned that formation of compounds involve things, right, combined in a fixed ratio. Right, your water has 2 hydrogen, oxygen has, for water molecule, you have 2 hydrogen atoms and 1 oxygen atom. right? Compared to mixture, mixture basically is just rojak, does not have a fixed composition. I want 10% water, 90% sand, that's fine, right? 50% water, 50% sand, yeah, it's still a mixture, doesn't matter, okay? Thirdly, your compounds are pure substances. They will have a fixed melting point and boiling point. Unlike your mixtures, they do not have a fixed melting point and boiling point. So for example, your seawater, okay, will actually melt at maybe around -1, okay, to 0 degrees Celsius, for example, and will boil at maybe 102 degrees Celsius to 103. Okay, so that's what I mean by not fixed anymore. So for pure substance, your pure water will melt at 0 degrees Celsius and boil at 100 degrees Celsius only. 1 point. Okay, but for mixture in pure substances, your melting point occurs over a range of temperature. That's what I mean by not fixed. Okay, if you need to read this up, this will be in chapter 3. Okay, and then your boiling point will be higher than usual. Okay, this will be a range of temperature as well. Okay, then next, your compounds actually have different properties as its constituent elements. So what do I mean by that? Just now I show you all, right? Hydrogen gas and oxygen gas, they are gases. But when I combine them to form water, water is actually a liquid, colorless liquid. Okay, so that's what I mean by different properties. Another more obvious example would be sodium and chlorine gas. When I combine these two together, I'm going to get sodium chloride. Okay, I've just put a number in front to balance the number of atoms. Okay, and then what do we know about it? This is actually a yellowish green gas. This is a silvery metal. Okay, I'll just write metal. And this is a white solid or white crystal, right? This is basically the salt that you eat every day or find in your kitchen. Okay, so we can see that they have different properties. They look differently, right? Their melting point, boiling point, everything is different as well. Okay, compared to your mixtures, mixtures have similar chemical properties. Water and sand mixed together is still water and sand, right? It's not different. Okay, when compounds are formed, there will be an energy change. Okay, a chemical reaction took place. What is this energy change? Is heat is being released or absorbed. After some chemical reactions, right, you may realize that heat is actually being released. If you go and touch the conical flask, etc., you may find that it became warmer or it became colder. If you do your practical, okay, you may observe these kind of things in the future. That's what I mean by chemical change, right? Heat energy is being absorbed or released when compounds are formed or when a chemical reaction took place, right? This will be covered in another chapter in Sec 4 as well. Okay. So when mixtures are formed, when I mix water and sand together, there's little or no energy change. Okay, so you choose what is easier to memorize for you. Okay, but usually this three is the more common one. Okay. Alright, then moving on. Okay, so that's all for elements, compounds, and mixtures. Quite straightforward, but also very important. Okay, now we move on to atomic structure. Okay, so inside an atom, okay, there are three subatomic particles. You have protons, neutrons, and electrons. Your protons and neutrons, they are found inside the nucleus, right? Collectively together, they are known as nucleons. Okay, so common mistake. Do not mistake neutrons and nucleons as the same thing. They are different. Why is this called nucleons? It's because they are found inside the nucleus. Okay, and then you have electrons orbiting around the nucleus. Okay. Okay, and then you have the properties of your proton, electron, and neutron. Okay, relative means in comparison. Okay, so proton and neutron have about the same mass. Okay, so we put 1 unit. Your electron is actually 1 over 1840 or 1836. You just follow your school. Both is accepted. Okay. What about the charge? Your proton is actually positively charged. How to remember? P stands for plus or positive, right? So +1. Electron actually has a negative charge, so -1. Neutron means neutral, has the idea of neutrality, right? So 0 charge. Okay. Yep. So this is really very important because you can go and flip through your TYS. They give you this 6 box, right? O-level combined chem TYS. You fill up this 6 box. That's 6 marks. Okay, quite common in school papers also, but they are less generous lah. Maybe they ask you for 4 box only. Otherwise, too easy already. Okay. Or if they very stingy, come out MCQ 1 mark. Okay, moving on. Okay, this is the chemical symbol. The larger number that you see in your periodic table, okay, that is the nucleon number or the mass number. It tells us the total number of protons and neutrons. Okay, so the mass of an atom can be calculated by adding the number of protons and neutrons. Okay, why don't we account for the electrons? Previously, we stated that electrons is so light, it's like 1840 times lighter than proton and neutron. Right? So the mass is more or less negligible. So we don't account for the mass of electrons when we calculate the mass of atom. Okay, so essentially your mass number is just proton plus neutron. Okay, and then the smaller number that you see in your periodic table, that's the proton number or atomic number. Okay, so do not be fazed, okay, by the different names. These two are interchangeable and they mean the same thing in exam. Okay, so you should familiarize yourself with these terms over here. Okay, and then, yep, I was mentioning about this. Proton number and atomic number tells us the number of protons this atom has. Okay, for combined science chemistry, very, very rarely the number of protons change. Okay. Next, atoms are electrically neutral. This is a very important keyword. Okay, they contain the same number of protons and electrons. Previously, we stated that protons are positive charge, electrons are negative charge. Same number of positive charge and negative charge, right? Hence, they overall have no charge, and we say that they are electrically neutral. Okay, someone asked, why is the bigger number on top for atomic structure, but in periodic table, the bigger number is below? Okay, so I don't want you all to memorize whether it should be at the top or below because there's different kind of representation. Okay, you can find other periodic table, the bigger number can be at the top, the smaller number can be at the top. It really doesn't matter. Okay, what's important is learning how to identify and make sense of those numbers, right? Your mass is made up of protons, right? Mass is now written, right? Your mass cannot be greater than your proton number cannot be greater than the mass number. Okay, so hopefully that clarifies the question. Okay, I will go into isotopes in a bit. Okay, hang on. Okay, so how can I calculate the number of neutrons then? Right, in math, M, the mass, equals proton plus neutron. Sec 2 math, you learn how to make the subject, right? So I shift the P over. Number of neutrons equals mass minus P. Essentially, I just take the big number minus the small number. Okay, that's what you have been doing in lower sec science. Hopefully, you still remember. Okay, you learned this in lower sec science actually. Okay, so this is the formula over here. Okay. Okay, then now we go on to isotopes. Okay, so what are isotopes? As you can see from the diagram, okay, the element is the same, H, H, and H. Okay, the number of protons is the same, but what is different is the number of neutrons. Okay, so if question asks you how to if question asks you to define isotopes, okay, you need to mention isotopes are atoms of the same element, same number of protons, different number of neutrons. These are the 3 marking points. Okay, if school is generous, they'll give you 2 marks. If they are a bit more stingy, then you get 1 mark for this, unfortunately. Okay, but whenever you see the word isotopes, I want your thought process to be clear because in exam, they will try to confuse you and then you will start to doubt yourself. Okay, so whenever you see the word isotope, just write this short form, same P, different N. Okay, before you get confused and then you doubt yourself. Is it different or is it same? Okay, that's what examiners will do lah. Okay, if your concept is not strong, you will get tricked and confused. Okay, is there anything else over here? Okay, yep. Okay. Okay, electronic structure and configuration. Whenever you see either of these words, what they are actually referring to is your something dot something dot something, all those things lah. Okay, how do you arrange the electrons, right, in the electron shell? Okay, so in the inner shell, the first shell, usually it holds up to 2 electrons. It's always filled first. We always fill from inside, go to outside. Okay, subsequent shells usually hold up to 8 electrons. Okay, and when we fill up the shells, right, we will fill it up singly. Okay, so for example, oxygen is 16,8, right? From this, I know that an oxygen atom has 8 protons. Previously, I also mentioned atoms are electrically neutral. Number of protons equal number of electrons. So 8 electrons. Okay, so how do I fill up 8 electrons, right? 1, 2. Okay, so I used 2 already. I'm left with 6. Okay, so how do I fill up this 6? Fill up singly first. Your school may tell you north, south, east, west, clockwise, anti-clockwise, doesn't matter. As long you fill up singly first like that. Okay, before pairing them up. Okay, then like this. Okay, this is the proper way to do it. Okay, so this is an example. Okay, electrons in the outer shell, they are called valence electrons. If the number of valence electrons is the same, right, the elements will have similar chemical properties. So what does this mean? Elements in the same group of the periodic table have similar chemical properties. Means the things that they can react with is similar. Okay, all right. Let's pause for a moment. There's a few questions. In one of the science camp, they both had the same character denoted by X. However, they have both different arrangement of the sign. There were 2 options given. They both had the same. Okay, Jake, I will come back to you later. Okay, cause I don't really understand the question. I need to see. However, yeah, okay. So it is 2.6. What is 2.6? Sorry, I also don't get what you mean. Yeah, what is 2.6? Why do isotopes have similar chemical properties but different physical properties? Okay, yep, good question. Also possible to come out in exam. So as mentioned, if something has similar chemical properties, always link back to the number of valence electrons. Okay, chemical properties is determined by the number of valence electrons and how it is arranged. Okay, but the arrangement doesn't really matter that much for combined science. Okay, for the physical properties, what are physical properties? Physical properties include your density, right? Mass, size, electrical conductivity, color, all these things are physical properties. Okay, things that you can measure in the lab. Alright, so previously in the isotope slide, okay, you can see that the mass number is different. Okay, but why is the mass number different? Because the number of neutrons is different. Remember, how do I get the mass number? I plus the number of protons and neutrons, and then I will get the mass number. Right, so different mass means different physical property already. Okay, but because they still have the same number of valence electron, right, they will have similar chemical properties. Okay, what's next question? Okay, yeah, correct. So oxygen electronic configuration is 2,6. Okay, hopefully I answered the similar chemical properties question. Okay. Okay, so I have this section of the periodic table over here. Okay, elements in the same group, same number of valence electron. Okay, your group number actually tells you the number of valence electrons the elements have. So group 1 means 1 valence electron, right? So this is the proton number, right? So if I were to write the electronic configuration, 21, 2.81, 2.8.8.1. Hopefully you can see the number of valence electron is 1. That's why they are classified in group 1. Okay. What about the period? The period actually corresponds to the number of electron shells that the atom has. Okay, this is period 1. Do not forget. Okay, most students will forget this. This is period 2. Okay. Oh yeah, something to mention also. when we write the group number, right, write the Roman numerals, okay? Otherwise, you will get penalized. But when you write the period number, we use the normal number system lah. Okay, so this period 2, period 3. So elements in period 2 will have 2 electron shells. Okay, I need 2 shells to fill this, right? This is lithium. What about fluorine? Fluorine is 9, so 2, 7. What about boron? 2, 3. So hopefully you can see, right? Elements in period 2 have 2 electron shells. So period number corresponds to number of electron shells. Group number corresponds to number of valence electrons. Okay, let me answer question. Okay, yep, can. Okay. Okay, can I just quickly check? Anyone find the pace too fast? Anyone else need me to slow down? Can sound off in the chat that I know. Just a quick feedback. Okay, anyone else? Everyone doing okay? Okay. Okay, that's the end of atomic structure. Okay, I'm going to chemical bonding. Okay, so you often see this keyword over here, stable electronic configuration. It's important that you know how to spell it correctly. Okay, so group 0 elements, they are called noble gases. These are your group 0 elements found in the last column on the right of your periodic table. Okay, we see that they have a stable electronic configuration. What that means is actually it has a full valence shell or full outer shell. Hence, they are unreactive and exist as individual atoms, or another word for it is monatomic. Okay, mono has the idea of one. So for example, you may often see this word carbon monoxide. And what's the formula of carbon monoxide? CO. Okay, this is a prefix that indicates one oxide. Okay, so common exam question also, they will ask you explain why noble gases are unreactive. You just need to simply state they have a stable electronic configuration and do not react with other substances, atoms, or whatever the question context is. Okay, so all your atoms will strive to want to become like a noble gas because this is the most stable state. Similarly, if I ask you to stand on one leg, you will not because it's unstable, right? You prefer to stand on two legs. So similarly, atoms will want to achieve stable electronic configuration if possible. So what are some ways that they can achieve that? Okay, yeah, this is what monatomic means lah. Okay, individual separate atoms. Okay. Just now you saw another one whereby the particles are like that, right? That will be called diatomic. Di means two. Okay, di means two. Okay. Okay, if anyone finds it too slow, just let me know as well. Okay. Formation of ions. So atoms can gain or lose electrons to achieve stable electronic configuration. Okay. Metals usually lose their valence electrons to form positive ions. So for example, I have a sodium atom here. If you look in your periodic table, sodium is 23, 11, and 8. Right? And then I mentioned the atom is electrically neutral. Number of protons, electrons is the same. The electronic configuration will be 2.8.1. After losing one electron, right, I will form sodium ion. So why does the sodium atom want to lose one electron again? It wants to kick this out so that it can obtain a full valence shell or stable electronic configuration, right? Now I have 11 protons, 10 electrons. 11 positive charge, 10 negative charge. Right? Overall, I am positively charged by 1 unit. Okay, so that is why you often see NAS plus. And the new electronic configuration will be 2.8 because this valence electron has been kicked out. Okay, so this is usually the case for metals. That is why you will often see Mg2 plus, Ca2 plus, lithium plus, what else? Al3 plus, what's next? Yeah, so on and so forth. Okay. And then your non-metals, okay, on the other hand, they will gain electrons instead to form negative ions. Because your non-metals are found on the right side of the periodic table, right? So means your group 4, 5, 6, 7, right? So the more efficient way to obtain stable electronic configuration is actually to gain a few electrons rather than kick out 4, 5, 6, or 7 valence electrons. It's not energy efficient. Right? The quickest way, most efficient energy way, okay, is to just gain electrons to get a full shell. Okay, and something to take note also, the name of a non-metal anion usually ends with IDE. So oxygen atom, right, when it becomes an ion, it will be called oxide ion. So just take note. Okay, chlorine become chloride. Okay, what about fluorine? Fluorine becomes fluoride. Okay, so let's observe this oxygen atom over here. Electrically neutral. So 8 proton, 8 electrons. Electronic configuration is 2, 6. Right? So how can it obtain stable electronic configuration? It needs 2 more electrons. So after gaining 2 electrons or 2 negative charge, it will have a charge of 2 minus. Okay, and the new electronic configuration now is 2, 8. Now it has attained stable electronic configuration. Okay, hopefully that's clear. Okay, so just a quick checkpoint. Hopefully you all can understand this is where you all can ask questions as well. You all can type your answer in the chat and I will check and go through. Right, just to make sure that everyone's on the same page, you all can understand this concept. Okay. Okay, so maybe how you all can present your answer will be something like that. Let me do the first one for you. You might need a periodic table. Something like that. Okay. Oops, sorry. Something like that. Okay, something like this. You all can type your answer like this, then I can check for you. Okay. This one just get from our periodic table. Remember, number of protons very, very rarely change. Cl minus means what? Gain 1 electron. So 18 now. Okay, remember IDE. Okay. Where is okay, most of your okay. Okay, remember a number of protons equal to number of electrons for atoms. Now we are dealing with ions already, yeah. So means they gain electrons or lost electrons already. Now there's a charge imbalance. That's why there is a charge. Okay, these are not atoms anymore. Okay, I think most of y'all got it. Yep, so remember, take note, these are ions. This one lost 1 electron already. Lost 1 electron means at first got 11, right? I lost 1 electron, now I am 10. Okay. Why do atoms lose gain the small? Where are you? Okay, yep, glad that most of y'all got it. Okay, magnesium is in group 2, means it has 2 valence electron. How to achieve stable electronic configuration? It will kick out 2 electrons. Right, but first and foremost, this one, this whole row I just copy from periodic table. After it lost 2 electrons, it should be 10 now. Okay. Yeah, most of y'all got it. Okay, very good. Okay. Wow, everyone doing good. Okay, okay. And remember the name. It's not iodine anymore. This is an ion, iodide. Okay. Oh, it's on the periodic table. Haven't memorized. Uh, 53. Right. I minus means what? I gain 1 electron. Now I have 54. Yep. Good that most of y'all got it. Okay. Okay, I'll hang around here for a while. Let your process and check. Okay, meanwhile, I'll answer some questions. Let me scroll back up. Okay, so someone asked, okay, for chlorine, right? If you look in your periodic table, okay, it's 35.5, sorry, 17. Okay, so how can chlorine gain stable electronic configuration? There is two ways. It can gain 1 electron, right, to form 2.8.8, or it can lose 7 electrons to form 2.8. Right, over here is 2.8.7 lah. Right, so what is more energy efficient? As I mentioned just now, it is easier to gain 1 electron than kick out 7 electrons. Okay, it's not efficient. Okay, is there anything else? Okay. Okay, then someone asked as well, what if it's group 4? Group 4 is in the middle, right? So does it gain 4 electrons or does it lose 4 electrons? That one we don't know. It really depends on what is more efficient in that sense. Okay. So it can form a positive charge or it can form a negative charge as well. It can go both ways since it's in the center. Right, so that's your carbon, sulfur, right? No, sorry, carbon, silicon, yeah, germanium, all those things. Okay. What is it? Okay, yeah. Just reminder again, we are dealing with ions, not atoms anymore. So all these have a charge because there is charge imbalance. The number of protons and electrons is not equal anymore, as you can see from the table, right? Number of positive charge and negative charge is not the same anymore. Therefore, the ions have a charge. All ions always have a charge. Okay, so you need to be clear what's an ion, what's an atom. Okay, atom is the basic form. Right? How are ions formed? Atoms gain or lose electrons to achieve stable electronic configuration. Okay, and then that's how ions are formed. So someone asked, when is it iodine and when is it iodide? Iodine is the element, right? Naturally, iodine exists as this iodine solid, I2. Okay, then we call it iodine lah. Okay, or we call it iodine I2, right? Means it exists like that. I. Wait, I. Okay, and we say one iodine molecule, this whole thing is a molecule, okay, consists of 2 iodine atoms. So when does it become iodide? It becomes iodide when it becomes an ion. So the difference is that this is iodine atom, hopefully you can see, but then this one is iodide, ion. Okay, atoms do not have charge. Ions will have charge because there is a charge imbalance already. Okay. The elements between the groups, they are called transition metals. Okay, for combined science, we will be mainly dealing with copper and iron. Those elements in the center of the periodic table can have various charges. Okay, so for example, iron can be 2+, iron can be 3+, or even other charge. Okay, we will not be looking at that today. That one is in another chapter. What if it's hydrogen? Okay. Hydrogen ion, there's two kinds actually. So hydrogen atom, right? Okay, hydrogen atom. Let me draw like that. Hydrogen atom. This is 1, 1. So what does that mean? I have one electron lah. One proton, one electron. Right? There are two possibilities to gain the stable electronic configuration. It can kick out this one electron to form hydrogen ion. You will see this in the You will see this in the acid chapter later. Okay, alternatively, it can gain one electron, right, to get two electrons, and then it will become like that. The inner shell need two electrons to have stable electronic configuration, right? This is the first shell inside. Remember, the maximum is 2 for the first shell. Okay, and we call this hydride ion. Okay, so hydrogen can go both ways. Most often, you will be looking at the top one. Okay, hydride is tested as a application, right? So again, if you realize IDE, right? So usually for anions, okay, or negative ions, you will have the IDE word inside. Okay. Why isn't O2 minus oxide? O2 minus is oxide. Did I write wrongly just now? Yeah, this is oxide, not oxygen. Okay, how do I find the number of electrons? Okay, for atoms, the number of electrons equal number of proton. Just look for the proton number, right? So in this exercise, you can see, right, a sodium atom typically has 11 protons, right? So that means sodium atom will have 11 electrons as well. How does it gain stable electronic configuration? It will kick out one electron. That's why plus charge. Kick out one electron, that means now my sodium ion has 10 electrons. Okay. For silver and zinc, those are special cases. I'll be going through them later. But if they kick I, isn't it not a full shell? Kick the electron. You mean for iodine, is it? It's not a full shell, is it? Okay, for iodine is a special case. My bad. Okay, this 288 rule thing, right, starts to break down after the first 20 elements. Okay, so just take note of that. Yep, so for iodine, but if they kick one, isn't it not a full shell? Okay, the hydrogen is still considered a full shell lah. This is still stable, means no shell at all lor. Right, your H plus ion. Yeah, it's still considered stable as long as it's stable. Yeah. Okay. So hydrogen can go both ways. Just take note of that. Okay, and hydrogen has one proton, right? It means it has 0 neutrons because the mass is 1. Mass is 1 means what? P plus N equals 1, right? It has one proton, therefore neutrons is 0. Okay. Okay. Moving on. Let me clear. Okay, so don't worry. If you need to clarify, you can always rewatch this lah. I suppose this will be uploaded. Okay. Then moving on to ionic bonding. Ionic bonding involves the transfer of electrons. Your sodium atom over here will kick out this electron such that it goes to the chlorine. Now both is happy. Now both has a full shell. And both of this is ion now, it's not atom, because the number of protons and electrons does not match anymore. Right? Your sodium atom lost one electron. Okay. Your chlorine atom gains one electron. Okay, so now you have these two ions, right? In primary school, we learned that opposite charges attract. So similar idea over here, right? There are opposite charges over here for the ions, and these strong electrostatic forces of attraction. This is the definition of ionic bond actually. Okay, hold the oppositely charged ions together. Okay. Yep, so for your dot and cross, just take note for ionic compounds, when we draw the dot and cross, we have to draw inside the bracket and then label the charge. After it lost one electron, right, it's plus charge. After it gained one electron, okay, or gain one negative charge, is minus charge. So when you draw the dot and cross, remember to check the symbol of the ion. Most students will happily draw X, 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 everything, then forgot that, oh, this electron actually came from the other element. So it's a different symbol. Okay. Okay, so smart exam tips. So some of y'all were asking just now, right? What about silver and zinc? These two are special. Okay, this can be found, silver and zinc can be found in the middle of the periodic table. So for exams, just memorize these 7 commonly tested ions and everything will be very smooth lah from there. Okay, the explanation will actually come behind after you learn certain chapters. Okay, so this is not to be confused with ammonia. Ammonia is a compound, NH3. Compound on the charge is already balanced. Okay, remember ions always have a charge. These are all ions, so they will have a charge. Okay, so I've grouped them in such a way. Okay, like minus minus, 2 minus 2 minus. This is your metals, transition metals that's found in the center of the periodic table. Okay. Do pure ionic bonds exist? Okay, pure ionic bonds don't really exist. It's actually a spectrum, maybe like 90% ionic bonding, 10% covalent bonding kind of thing. Yeah, there's actually a mixture of both, but which one is more dominant or which one is the majority? Yeah, okay. Is it true if A has a charge of 3 plus, so B has a charge of 4 minus? Okay, when compounds are formed, you have to balance the ionic charges. Okay, so if A is 3 plus, okay, so I just write here. A is 3 plus, and let's say I have a B of 4 plus or B of 4 minus. Okay, plus and plus, like charges, they are going to repel. They are not going to form bonds lah. Okay, but these two can kind of pair up together. Okay, I will go through that in a bit. Chemical formula, oops. Right, yep, this is the one. Okay, so chemical formula. The formula of an ionic compound can be constructed by balancing the charges of the ions. For example, if I have magnesium 2 plus ion and oxide 2 minus, right? If I want to form a chemical bond between them and then form a compound, what will be the formula of the compound? It will just be MgO, 1-to-1 ratio. I need to balance the charge, right? 2 plus cancel out 2 minus, both is happy, right? And then this is called magnesium oxide. Okay, yeah, I will go into that later. Okay, copper 2 plus, right? And Cl minus. Okay, how can I balance out the 2 plus? I will need 2 units of this so that I have minus minus. Minus minus then can cancel out the 2 plus. Therefore, my chemical formula of the compound form between these two ions will be CuCl2. Okay, and then what's the name of this? This will be called copper 2 chloride. Okay, so for combined science, you will be seeing copper and iron very frequently for transition metals. Okay, the one in the center that some of y'all were asking. Okay, so what does this Roman numeral represent? Okay, it represents the charge of copper because copper can be plus also. So if you just write copper chloride, you will get wrong because are you referring to copper plus or copper 2 plus? There are even other possibilities also, so you need to be specific, right? So scientists use Roman numerals to indicate the charge of the transition metals. Okay. Then sodium ion and carbonate ion. This is one of the 7 that you need to remember, right? I have 2 minus, so how to balance? I need 2 units of this, right? So I write Na2CO3. Okay. So why don't I put the 2 in front like this? Okay, when you put the 2 in front like this, like math, you are going to kind of treat it as expansion. It's 2 of everything, 2 units of the whole thing, okay, which is incorrect. So we put the 2 over here as a subscript. Okay. These are considered polyatomic ions. So break up the word Poly means many. Okay, these ions are made up of many atoms. Okay, we can see that this ion is made up of 4 atoms. This ion is made up of 2 atoms, O and H. Okay, for this one, it's made of 1 carbon atom and 3 oxygen atom. Okay, so for polyatomic ions, we need to use brackets if we require more than 1 unit to balance the charge. In this case, I have 2 plus. I have minus here, right? So how do I balance the charge? I need 2 units of this. Minus, minus, then can cancel out. But how do I write 2 units of hydroxide? I have to write it in brackets and then the 2 over here. This means that I want 2 units of this, okay, to balance the Ca2 plus. Okay, let me answer the questions. You need to put bracket for compound. What bracket for compound? For polyatomic ions, right, such as this one in the previous slide. Okay, these are your polyatomic ions. This is not given in the periodic table, so that's why you kind of need to memorize. Okay, your other elements you can get from your periodic table. Don't need to memorize. All these 7 is not given in the periodic table. Okay. Okay. Someone asked a good question. Okay, why is chlorine 35.5? Okay, what does this mean? Okay, this one you will actually learn under the mole chapter. It is because of isotopes. Okay, so 75% of the chlorine actually has a mass of 35. Okay, 25% of the chlorine atom on Earth actually has a mass of 37. Okay, and then this 35.5 is actually the average mass. How do I calculate it? 75 over 100, 75%, right? Times 35 plus 25% times 37. Okay, if you calculate this out, you are going to get 35.5. This 35.5 is the average mass. Okay, if exam asks you why is some mass number or relative atomic mass not an integer or not a whole number, you simply need to state due to presence of isotopes for 1 mark. If it's 2 marks, then you need to mention the mole part, whereby the 35.5 is the result of the average mass. Okay, that one will be covered under moles, which I won't go through much over here. How to find abundance? You are not required to memorize abundance. Question have to give you. At most, you need to perform the calculation only. Okay. Okay. Okay, going on. Okay. If OH minus need to put brackets, why? Okay. Why OH minus need to put bracket? Why CO3 over here don't need to put bracket? Because I only need 1 unit of this, ma. You only put brackets if you need more than 1 unit to balance the charge. I need 2 of this to cancel this out. That's why I put bracket and then 2 over here. Yeah. Okay, so that's why your carbonate over here don't need bracket. I only need 1 unit of it. Yeah. Okay. Okay. Chemical formula. Okay. An alternative way, if you struggle with mental sums balancing the charges, you can use this. It's called the crisscross method. Your school probably teach you also. Okay, you just write out the ions separately and then you cross diagonally and then you simplify the ratio at the end and you will get the formula of the compound. So these are some examples. Right, and then over here you can see you need to simplify the ratio. Over here can divide by 2, over here can divide by 2 also. So 1:1 ratio. So if you are using the crisscross method, just remember to simplify the ratio. Okay, and what are some characteristics of ionic compounds? Okay, keyword over here is general. There are exceptions, okay, but this is general, majority of them, right? Majority of them will consist of a metal and a non-metal. So that's how you identify ionic compounds. They will have a high melting point and boiling point. So if exam asks you explain why sodium chloride, sodium oxide has a high melting point, or explain why this substance is a solid at room temperature, Okay, you need to say that because this substance, let's say sodium chloride, has a giant ionic lattice structure, a large amount of energy is needed to overcome the strong electrostatic forces of attraction. This is essentially explaining what ionic bonding is. Okay, and between the oppositely charged ions. Okay, so this is the minimum already that you need to secure the full 2 marks. Okay. Next, ionic compounds conduct electricity in the molten state and aqueous state in general due to mobile presence. Electrical conductivity always link back to mobile ions and mobile electrons. If you have either one, you can conduct electricity. Okay, and ionic compounds are generally soluble in water but insoluble in organic solvents. For this, the exceptions you need to know that will be under the salts chapter. In salts chapter, we learn about ionic compounds, right, or salts that are insoluble in water. So those are the exceptions. Okay. Okay, moving on. Covalent bonding. Covalent bonding involves the sharing of electrons. Previously, we have ionic bonding. Ionic bonding involves the transfer of electrons. Totally give you, right? The sodium totally give the electron to chlorine to form sodium chloride. Okay, but over here, I share electrons. Okay, so basically there's two ways in which atoms can achieve stable electronic configuration, gaining and losing, or sharing electrons. Okay, so if they share electrons, these are usually for your non-metals. Okay, and yep. So in this case, let's say if I want to form chlorine molecule, okay, two chlorine atoms, one atom, the second atom. Each of these chlorine atom needs one more valence electron to achieve stable electronic configuration. After sharing one electron each, both chlorine atom will be able to attain stable electronic configuration. That is why some elements exist as diatomic molecules. So common exam question again, explain why chlorine gas exists as a diatomic molecule. Why doesn't it exist as an atom like that on its own? Okay, it's because they want to achieve stable electronic configuration. And how can they do it? By sharing electrons in this case. Okay. Okay, so just now we have the case of an element, right? There's only one type of atom over here, right? Just chlorine atom. So this is a element. Covalent bonding can occur in elements and compounds. So just take note. Okay. So if electrons are shared between different type of atoms, that's when a compound is formed. Okay, so for example, carbon dioxide. Carbon dioxide is made out of carbon atom and two oxygen atoms. So in general, the trick is that the number of electrons each atom will share corresponds to how many more valence electrons it needs. So for example, carbon needs 4 more valence electrons. To achieve stable electronic configuration, it will share 4, as you can see over here. Okay, it will share all 4. Your oxygen need 2 more, right? So each oxygen share 2. Okay, hopefully you can see over here. So this is just a general guideline. It works most of the time. Okay, how many electrons it need is how many electrons it will share when you draw your dot and cross diagram. Okay. So for covalent substances, what are some general characteristics usually occur for non-metal atoms? And it will have a low melting point and boiling point. So how do you explain this low melting point and boiling point, and how do you explain why these substances usually exist as a liquid or gas? It's because they have a simple molecular structure, a low amount of energy needed to overcome the weak. Okay, since the forces is weak, you just need a small amount of energy, right? Intermolecular. Inter means between. Between what? Between molecules. Okay, so you have this thing over here, this diagram over here. So very common misconception, your covalent bonds formed from the sharing of electron is very strong. When you are melting or boiling this kind of covalent substances, right, you are not trying to break this, you are not doing that. What you are trying to overcome is the weak intermolecular forces between the molecules. You are trying to overcome this. Okay, so do not write the strong covalent bonds. Okay, common misconception over here. Covalent bonds are strong, but for covalent substances, what you are trying to break when melting or boiling is the weak intermolecular forces. Okay, next. Your covalent substances will exist as separate individual molecules. 1 unit, 2 unit, 3 unit, 4 unit, right? Separate individual molecules. Generally, they are soluble in organic solvent. You will learn organic chem in the last 2 chapters of Sec 4. For now, organic solvent, just treat it as oil, right? We learned that water and oil does not mix. Okay, so just treat it as that for now. Your covalent substances do not conduct electricity in any states apart from acids. For example, hydrochloric acid, right? This is a covalent substance, non-metal, non-metal. When dissolved in water, it can conduct electricity. This one I'll cover later. Okay, what's this? In covalent bonding, do we need to draw another circle with 2 dot? Do we need to draw another circle with 2 dot in the element like O? Okay, the number of dots in between over here, right, in the overlapping area, okay, depends on how many more electrons these atoms need to achieve stable electronic configuration. It's not that it's always 4 inside, it's not that it's always 2 inside. It really depends. Right? Remember, the main goal of these atoms is to achieve stable electronic configuration. How can it obtain a full valence shell? Yeah, that should be the guideline rather than memorizing which one got 2, which one share 4, which one share 3, okay, so on and so forth. Okay, so these are some common covalent substances, right? These are your diatomic molecules, so take note. This is how all these elements exist on Earth. They don't exist as individual atoms floating around like that. Remember why? Okay, they would want to pair up with each other to obtain stable electronic configuration by sharing electrons. Okay, so over here on the left, these are your elements. You only can see one type of atom, right? Over here on the right, these are your covalent compounds. You can see more than 2 capital letters. Okay, that you will often see in your journey of combined chem lah. Okay. Okay. Question: will you have to draw the non-valence shell? Okay, very good question. So for dot and cross, do we have to draw the inner electrons or not? That will depend on the exam question requirement. Okay, most of the time they will just ask you to show valence electrons only, and you give them what they want. If they never write that phrase or statement, do not assume. Just draw everything out, including the electrons in the inner shell. Means the first shell got 2 electrons, all those. Okay, draw everything out. Okay, maybe let me see if I can find, where is it? Okay. Okay, so an exam tip for y'all as well. Go and study dot and cross. Confirm plus chop 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 come out. Okay, if your school is generous, they will give you both kind of dot and cross, the ionic and covalent one. Right, to prove to you, I will just control F this thing. Right, you can see, right? Yeah, this is the latest test papers out there lah. Okay, so I just type dot, you see. Okay, you can see 15 finds. From 15 school, no, from 8 test paper, the word dot appear 15 times. Almost every school tests both dot and cross diagram. Okay, so this is Sec 3 end of year, right? So you can see confirm plus chop come out one. Okay, so go and study dot and cross. Go and refer to your notes, whatever. Okay, so I will just show you. Let me see. Yep, so in this question, show outer electrons only. Okay. Let me see if I can find one that does not show. Okay, showing only valence electrons, so outer shell only. Valence again. Okay. Over here they specifically said show all electrons. They need to draw the electrons in the inner shell also. Okay, what next? Over here, they never mention anything. You don't assume, okay, that you draw valence electrons only. You have to draw everything out. Okay, so these are the kind of phrasing that you can expect. Okay. Oops, sorry. Okay, let's come back to the slide. Okay, stay strong, guys. Last one. Okay, acids. What are acids? Acids are substances that dissolve in water to give hydrogen ions. Okay, so if I throw this inside water, this thing is going to break up into H plus ion and Cl minus. So just now remember I said your acids, they are covalent substances, yes, but when you throw them in water, they are going to dissociate or break down into ions. And these ions can move around, float around inside your solution. Hence, acids can conduct electricity. Okay. What are some other characteristics of acid? pH less than 7. It will turn damn blue litmus paper red. This one must write them. The moment you don't write them, 1 mark gone. Okay. Because water is very important in this chapter. If there's no water, this thing will not behave as an acid. For something to behave as an acid or alkali, water needs to be present. So this word damp or moist is very important. The moment you don't have it in your answer, 1 mark gone. Yes, moist also accepted. For dot and cross, don't need to be so concerned about the actual size. Where can we find the mini? Okay, yeah, for those of you who joined late, I haven't sent the revision kit yet. Yeah, okay. Okay, then we have bases and alkalis. So these are substances that you need to know. What are they? Okay, bases are metal hydroxides or metal oxides. This is just a general term, bases. Just like animals and plants, we need to know how to distinguish them. And then we have alkalis. Alkalis are special bases that can dissolve in water. And when they dissolve in water, they give you hydroxide ions, okay, OH minus. So for alkalis, the pH will be greater than 7. If something is neutral, then pH equals 7. Only equals 7, nothing else. 7.00001 is not neutral already. So the same thing needs to be damp as well. Okay, common exam question, 3 mark, 1 mark, can be MCQ open-ended. What can you add to the soil to neutralize the excess acid? Okay, what's this question? Try not to use wet, use moist and damp. If you use wet, your teacher may give you benefit of the doubt. Yeah, okay. Right, so these are some common acids that you will see very often, just 3. Okay, hydrochloric acid, nitric acid, and sulfuric acid. And then you have the general reactions of acid. What can acid react with? Metal, base, and carbonate. So when acid metal react together, you're going to get a salt and hydrogen gas. This is a gas. When acid plus base, just now I mentioned base is metal oxide or metal hydroxide, you are going to get salt and water. This is water, no gas over here. Acid plus carbonate, you are going to get salt, carbon dioxide gas, and water. Okay, so this is really important because if you don't understand this, you realize that in the salt chapter, you're going to die very badly, and that's when your marks will plunge down all the way. Okay, so most of y'all will find yourself struggling for a salt chapter because salt chapter need ionic bonding and need acids to be strong. Okay. Is there a difference for calcium hydroxide and oxide? Yes, there is a difference. They are different substances. Calcium oxide is this, right? So the name, this oxide, right? So O2 minus and Ca2 plus. If you're wondering how I get this. Okay, calcium hydroxide. What is hydroxide? Hydroxide is this OH minus, Ca2 plus, and OH minus. How to balance the charge? Just now we saw, right? I need 2 units of this. That's why I write bracket 2. This is calcium hydroxide. So there's a difference. There are different kind of substance. One got H, one no H. Okay. So next. Common alkalis, you will see these 3 as well. Sodium hydroxide, potassium hydroxide, ammonium hydroxide. Or sometimes your school may refer to this as aqueous ammonia. Okay. So for your alkali side, only one reaction. Okay, alkali plus ammonium salt, you're going to get, oh, there's a mistake here. Salt plus water plus ammonia gas. Okay, this is the gas also. So can think of it, carbonate, you're going to get carbon dioxide. Ammonium, you're going to get ammonia gas. Okay. If you look at your textbook and your notes, there will be two reactions over here, alkali plus acid. But it's actually the same as this one over here. Alkali is a special kind of base. Right, so acid plus alkali give you salt and water. So, okay. Differentiate non-metal and metal oxide. Just look at the chemical formula. Yeah, you just need to look at the chemical formula. Okay, that one I'll go through in a bit. It's behind. Okay, this one I will skip because we kind of lack of time. Okay, so type of oxides. Okay, so there are four different kinds of oxides. The first one, amphoteric. Amphoteric oxides, they are metal oxides and they can react with both acid and alkali. So for amphoteric oxides, mainly these three need to memorize as well. There's this acronym over here, ZEP. Okay, so someone asks, how do I identify whether it's a metal oxide or non-metal oxide? Right, this is the oxide, right? So what is it paired with? Paired with zinc. Zinc is a metal, so metal oxide. Aluminium also metal, lead is also a metal. Okay. What about the opposite? For neutral oxides, they are non-metal oxides. You can see these are non-metal and they do not react with acids or alkalis. So amphoteric and neutral, they are like kind of direct opposites. So same thing, three examples to memorize also. Star this. This one very high chance will come out. Amphoteric, according to trend, is the highest chance of coming out. Okay. If like got a certain chemical formula, how do you tell if it's a base or alkali? Okay, so base and alkali. So back to this. Okay, so alkali is a special kind of base that is soluble in water. So alkalis, they are hydroxides. Okay, usually lah. So just now I mentioned the three common alkalis. Right. Usually for alkalis, we will be dealing with these three. Okay, because most of the bases, right, most of the metal oxides and hydroxides, they actually don't dissolve in water. Yep. Okay, so for alkalis, just these three. The rest, more or less, considered bases very often. Okay. Over here, I'm just generalizing and simplifying things a lot. How about acidic and basic oxides? Yes. Sorry, coming back to that. Okay. Yeah. So I mentioned four types of oxides, right? Amphoteric and neutral. Now we have basic and acidic. Okay, basic oxides, they are also oxides of metal. You can see metal. But the thing is that they only can react with acids. Okay, base and base don't react. Base and acid can react, right? That's why they only react with acids. Okay, your acidic oxides, they are non-metal oxides. On the other hand, they react with alkalis only. You can see non-metal. Okay, so how do I determine whether something is amphoteric, basic, acidic? Like, how do I classify them, right? So for basic oxides, you need to check there is a metal oxide that is not Z. So for example, this is a metal, right? This is not zinc, this is not aluminum, neither is it lead. So all these are examples. Okay, this one don't need to memorize because it's the rest basically. As long as not Z and it's metal oxide. Okay. For your neutral oxides, we have these three examples just now. Anything that is not these three and is a non-metal oxide, we will classify it as acidic oxides. These are the common examples that you will see. So just take note, be very careful. This is carbon monoxide. This is a neutral oxide, right? Another hint is that you can see that these are monoxides, only got one O. Okay. This one is carbon dioxide. Carbon dioxide is actually an acidic oxide. Your carbon dioxide can dissolve in water to form an acid called carbonic acid, actually. Okay. What's next? Okay. How do you remember that basic oxide equal metal oxide? And you have to practice the thought process. Unfortunately, there's no way around this thing. Yeah. How to differentiate? Uh, how to differentiate pH value and universal indicator. Okay, hold on to that. Do we need to know that neutral oxides cannot dissolve in water except for water? In what kind of question does this come in? Okay, the key thing to identify what kind of oxides we have, usually question will say I have this unknown oxide. Okay, this unknown oxide can react with this and this. So we need to look at the main criteria, which is what can it react with. Okay, and then we need to consider is it a metal oxide or non-metal oxide. The moment we can identify that it's a metal oxide or non-metal oxide, we have a 50% chance already. So metal oxides include basic oxides and amphoteric oxides. Non-metal oxides include acidic and neutral oxides. Okay. Okay, so some of y'all may be wondering what's the difference between the names, right? You see this over here. Okay, mainly these two lah. Okay, sulfide is actually 2 minus. Sulfate is actually SO4 2 minus. So the thing is that for ATE, right, you will see carbonate also, right? When you see the word ATE, it means there's oxygen inside and it's a polyatomic ion. Okay, when you see IDE, usually it means that it's alone lah, apart from hydroxide. So just now you see iodide, right? Iodide means what? I minus. When you see chloride, chloride is Cl minus. Oxide, oxide is O2 minus. Okay, both metals and non-metals have A inside. Both metals and non-metals have. Okay, wait, I go on first. Okay, I think the rest can try this. Okay, y'all can try this. Both metals and non-metals have. Both metals. There is empathy. Then the non-metals. Maybe ply. This is. Yeah, let me try to understand. Both metals and non-metals have A. Z. Okay. Non-metals has the other A. Is the chemical properties of alkalis the reaction? Yeah, correct. The chemical properties is what can alkalis react with basically. Yeah, right. Inventory. Okay. Okay, I will just quickly go through this. Okay, so from the information given, you need to identify the kind of oxide that they want. Dissolve in water to form pH lesser than 7 means an acidic oxide. Okay, so this will be A. Does not change the color of damp blue litmus paper or damp red litmus paper. This is neutral oxide, so carbon monoxide. Reacts with acid and alkali. Remember this one, your alkali, sodium hydroxide. This is your Z. Zinc, aluminium, lead, okay, and ferric oxides. Dissolves in water to form an alkali solution. Remember what are the three common alkalis? Oh wait, this one also C, sorry. This one also A. Did I forget to change something? Oh, I think I forgot to change something. This one... Okay, this one, the best answer in this case would be D. Okay, because there's no sodium... Yeah, there's no sodium oxide or potassium oxide over here. If there's sodium oxide or or potassium oxide, that would be the answer. Okay, I think I forgot to change this. Okay, what are the questions? Can sulfur dioxide be A? Yep, okay, cover that. Okay. Okay, how can you distinguish between acidic and alkaline solution? For simple tests, you can add universal indicator, right? Or you can add your litmus paper. Use your litmus paper temp, like damp blue or damp red, and see if it changes color or not. If you add universal indicator, then you have the rainbow color. Okay, I didn't include that over here, but I have red, orange, yellow, green, blue, purple or violet. Okay, green is pH equals 7. So this is the acidic region. Okay, this is the alkali region greater than 7. Okay, so just take note of the colors over here. Okay. Okay. Okay, yeah, so that's the end of the revision, but hold up. Okay, so for those of you that are interested in working with me, okay, there is this combined camp group tuition. The official start date will only be in November. Okay, if you are interested, you can just indicate your interest over here. Okay, I'll explain more about this later. The duration is 2 hours weekly and the rates are as follows. Group size will be 1 to 12, but for now the group size will be much smaller. And this is something to take note also, limited slots available only because yeah, I don't really have much time or yeah, okay, my schedule is quite packed lah. Okay. So probably accepting around 20 students only for next year intake. There are current students already lah. They are in the Sec 3 class. Okay. Yep. So oh yeah, by the way, this is the classroom if we were to hold it in a physical location, something like that. Okay. Yeah, but let's quickly go through this. Okay, so this is the timeline on the rough plan for November, December, and maybe January. I'll be recapping the key Sec 3 topics because if I don't cover this, right, the future topics in Sec 4 may be affected because your foundation is not strong. So a lot of y'all may have realized that after certain topics, right, your marks start to go down because foundation gaps are there and it's not being plugged. Okay. For Jan and May, I'll be focusing on the Sec 4 topics following your school. Right, this is just a general guideline. For June to August, I'll be preparing you for prelims. We'll look at trending exam questions. How do we break down complicated questions? Right, exam techniques and consolidating all the knowledge that we learn. How do we link? How do we memorize things more efficiently? And of course, there will be the practical component as well. I don't have a physical lab, but I actually have a special method to go through practical component. For last year, I think all students got A. For this year, I haven't get the prelim results yet, so I'm not sure, but the one student doubled their marks from 5 to 9 lah. Okay, after one lesson, just one lesson going through practical like that. Okay, so I have a special way to go through practical. For chemistry practical, it's very predictable. Okay, and it's 7.5% of your total grade because combined science, right? So 7.5% will be from chem, 7.5% will be either from physics or bio. Okay, and then lastly, we will work towards O levels. Okay, I will take a look at your prelim paper and see how can we improve, right? What are your strengths, right? Things like that. And then we will be mastering the content. We will be practicing under time conditions so that you know how to deal with stress better. We will be working on the 10-year series as well lah, and looking at exam trends. Okay, so that's a rough guideline. Okay, so there are several promotions over here. For the early bird, for those of you all that sign up before 30th Sep, you'll be entitled to 3 curated notes, any 3 subjects. Okay, one of it will be the subject that you sign up for. And then you will have priority selection for the classes and time slots. So when the classes open up, when my schedule frees up, right, I will be contacting you and trying to arrange a time slot for this group tuition thing. The venue, the time, the day, everything, all this. And you also receive a end of year exam kit. You'll receive these slides. You will get the commonly tested questions, right? I have compiled them. So additional materials like in on top of the revision kit today. Okay, so this is just bonus stuff. Okay, next. And you have the trial package. So if let's say you're uncertain, right, it's okay. You still can wait a bit more, right? There will be free trial class in November. You can sign up with your friends. It'll be more fun. Okay, classmates and stuff. Okay, you can be entitled to free. You'll be entitled to 2 sets of free curated notes, and you will be selecting the existing classes and time slots. Like means the class is already there. Okay, this will be until 31st October only. Okay, do you teach and what's the price for pure chem? Okay, the price is the same for pure chemistry, and that will be by another tutor, should be lah. NA, you can express your interest. We will see how. Yeah, okay, for NA. Okay, for the normal intake, right, for the rest of you, the first trial lesson is free. You will be entitled to 1 curated note also, just the subject that you sign up for. But take note, the slots also subjected to availability. So just now I mentioned limited slots, right? Okay. So I need to see whether I got slot or not. I don't want to take up so many students because I want to focus on helping these students really get an A. My aim for the class is 80% A, which is very doable. Okay. I will show you how it's done. Okay, so just a word of encouragement for you all before we proceed to the giveaway and the Kahoot quiz. The Kahoot quiz consists of exam questions lah. Okay, just a few hard ones and the rest are very easy. Okay, but before that, just a word of encouragement. I know some of you have been struggling with chemistry, but do not let this failure or past results affect what you can do in the future. Okay, failure is merely an event. It's just one scenario. It's not a person. Okay, you are not a failure. I heard of stories, students telling me that their teachers scold them, their parents scold them, that made them feel so bad, right? Uh, don't get too affected by it. Continue pressing on. I'm sure you will see results. Okay, don't let just a few setbacks hinder you from achieving what your maximum potential and dreams is. Okay, do not do your exams with a defeated mindset. It's really important. Okay, each test and exam, treat it as another chance to prove yourself, to check your growth. Okay, treat it as a form of feedback. Did I do better than last time? Okay, strive for improvement. Don't aim for perfection. It is normal to have things that we don't know because examiners will have to come up with hard questions. Otherwise, everyone full marks already, right? So accept the fact there will be things that you don't know. Okay, this is for the general population. I know there are students aiming for 95 and above that kind, but for the general population, right, strive for improvement. It's less stressful. Don't aim for perfection. Okay, take one step at a time. Okay, so for the free revision kit, you can scan the QR code or I'll paste the link in the Zoom chat as well, whichever works. Let me go and get it. Okay, wait. Where is the okay, yep, you can scan the QR code for the free revision kit. Okay. Give me a sec. Let me just close this a while. Okay, whatever I covered today is applicable for NA as well, for pure chem as well. Okay, let me get the link for the revision kit. Then I'll put up the, oh no. This one. Okay, this is the link. Oh, okay. Oops, sorry, there's a change in the link. Okay, you scan the QR code first. For those that need the link, I will put it in the Zoom chat later on while y'all do the Kahoot. Yeah, I need to get the new link. Okay, cause I updated the thing. Okay. Yep, so get ready your periodic table, pen, paper, calculator, whatever you need. Right, the top scorer will walk away with one set of curated notes of your choice. Will you accept NA students? Is it for NA only? Timeline for NA students will be more lax, okay, because there's lesser things to go through lah. So that's the general plan that I have. Of course, it really depends on the students as well, because different schools also teaching different things. So I'm willing to see how it goes. If you are NA, just input in the comments, all right, then we will try to arrange. Okay, yep. So okay, later I'll have this QR code for the revision kit as well. Okay, I'll go on to the Kahoot first. Okay, let me get it. Okay, so don't stress, just treat this as a game. Okay. These are actual exam questions. I don't think there's another Sec 4 crash course. The crash course is done by another tutor. Yep. Let me see. Yep. You all can join the Kahoot over here. Meanwhile, I go and get the link. Oh wait, I can't. Let me see. There is no Sec 4 revision Zoom as well, unfortunately, because they did Sec 4 crash course. Yeah. Yep, I do have advice for loss of motivation. But now it's still early. Now you still have a lot of time. So don't worry, take one step at a time. Now your enemy in front of you is end of year. Okay. 1 year is a lot of time. I have students jumping from E9 F8. No, F9 E8 to A B in like few months. So it's really possible. Electrolysis is for pure chem. I'll be showing the QR code later again. Yeah. Okay, sorry, I know it's a bit late. Okay. Any more students? We have 75 participants, only 61 over here. Okay, I'll just wait for 30 seconds. Okay, any more coming in? Okay, 5, 4, 3, no one else? 2, okay, wow. Okay, yes, 74. Oh, what happened? 74 I start, Okay, everyone's in, nice. Wow, so fast. Okay. Okay, that's more than half, 3/4 probably. It's a compound made up of two different type of atoms. How do I know? I see two different sides. Okay. Okay, next. Yep, speed up a bit. This will take about 10 to 15 minutes. Okay. Work backwards. We know lithium is group 1. This is group 5. Okay, not too bad, not too bad. Lithium is group 1, so it will form Li plus. Phosphorus is in group 5. 3 minus. How do I balance the charge? I will need 3 lithium. Okay. Next. Okay, if you all have any other questions, you all can ask me after that later as well. Okay. Yep. So for that, there's actually an ionic compound. Ionic compounds only can conduct electricity in the molten and aqueous state. It cannot conduct electricity in the solid state. But it has a high melting point. Okay. Easy. Okay. Whoops. Okay, this is the wrong answer. This is a mixture. This is compounds. Sorry about that. 40 to 40. Okay, most of y'all got it. Okay. I will check the score later. Okay, so don't worry about it. Let's go. Who got it? Okay. The top few not affected. How y'all choose so fast? The link. Okay, there is only 4 capital letters. So 4 different elements. Calcium is group 2. So you'll form 2 plus ion Y. It will kick out 2 valence electron to obtain stable electronic configuration. If this is 2 plus, that means this thing has to be minus minus. That's why I have 2 over here. Okay. So question asking for incorrect, by the way. Okay, so these are actual exam questions. I took it from the exam paper. Isotopes, same number of protons, okay, which is atomic number. Different number of neutrons. That's easy. Magnesium ion, not atom. Okay. Ion, lose 2 electrons already, so 2, 8 only. This 282 is the atom. What kind of substance is this? Okay, this is a covalent substance, right, with simple molecular structure. It's not an acid, so it does not conduct electricity, and it has low melting point. Okay, almost there. Okay, this is one of the hardest one. How you all choose so fast? Okay, if you are given the number of protons, right, you can actually go and match your periodic table. Remember I mentioned that proton usually don't change. This is actually magnesium over here. 12, proton number 12. This is actually neon over here, proton number 10. So magnesium is a metal, neon is a non-metal. Alright, so answer is A. Okay. Also commonly tested. Open-ended will be 2 marks lah. Okay, this one just need to memorize more or less. Okay, ionic equation for any hydroxide and acid. Okay, 95% of the time is just H plus plus OH minus. Acid plus alkali, which is known as neutralization reaction, okay, give me water. Okay, they will try to distract you with a lot of nonsense. Okay, your methylamine is an alkali because pH greater than 7. Alkali plus acid give me a salt. Okay. Okay, almost there. No more hard questions. I think the rest are very easy. Okay, from this you should know, can we have acid and alkali, amphoteric? Okay, common exam question. Amphoteric, zinc, aluminium, and lead. Okay. Okay, I'll stop at 20 seconds, 10 more seconds. Okay, any final answers? 3, 2, 1. Okay, from this, then red litmus paper turns blue, means alkaline gas is coming out. What is coming out? Ammonia gas is coming out. What produces ammonia? It will be your alkali plus ammonium salt. Okay, and that will be over here. Ammonium salt and alkali. Okay, give you ammonia gas. Okay, last one. Yep, 15 seconds. Okay, just even shorter. Okay, very common. If come out open-ended, also 1 mark. Okay, calcium hydroxide. This is fixed. Okay. Yep. Okay. Then this one, just need some feedback. How do you all find today's session? So that I can improve on the physics one. If you are coming for the physics. Okay, yep, just faster put. No need to think so much. Okay. Yep, okay. Okay. Oh, wow. Okay, skip lah. Okay, my button. Okay, who is the winner? Okay, nice. 12 out of 15. Okay, that's good. 12 also. Faster. Okay. Okay, can Sin PM me on the chat, private message me. Okay, then now let me go get the link. Okay, let me. Okay, if you have any questions, you can ask me as well. Let me go get the link for the revision kit. Yeah, regarding the tuition, anything you want to clarify about chem? Yeah, all this is fine. Link. Copy link. Okay, then put it over here. Okay. Okay, wait. How to revise better? Okay, this is the link for those. Okay, how to revise better for chemistry? Okay, chemistry you need to revise or memorize efficiently. You need to know how to use the periodic table. If you know how to use the periodic table, then you have lesser things to memorize. Yeah. Okay, in fact, chemistry is one of the easiest science. You're not going to find another subject whereby you write one letter, one word, get 1 mark. In your TYS, you'll actually see a lot. In school papers also. Okay, yep, you can just PM. Okay, any other questions? Yep, I've send the link in the chat for the revision package, right? If you all need to download it. Yep, otherwise that's the end. If you all have other questions, feel free to PM me. Ask. Fine. Okay, TYS answers I do not recommend because actually a lot of them do not have the keywords. Yeah, welcome. Okay. If your teacher got give you the solutions or answer key, that would be much better. Yeah, do not rely on TYS answers. Some of them missing out the keywords or too long-winded. Do you recommend any book for chem? For combined chem, I would say practice the TYS is sufficient. Chem MCQ. For combined chem MCQ, usually they are very nice. If you practice elimination, you should have a scenario whereby most of the question is a 50% chance.